When we left off on the last video, we'd worked this problem and gone through it. This problem looks like a whole lot of problems that are on your practice test. So if you want to pause the video and get out your practice test, it might be a good idea. The problems on the practice test that it looks like are the ones on the front page 1 through 12, with the exceptions that we were talking about earlier of 1, 2, 3, and 10. Those are all ones like we had worked previously that didn't have any parentheses in them or any like terms to combine. I'm going to pause the video right now so that you can get out your practice test. I'm going to work one of the problems part of the way through for you to kind of help get you started on it. The problem I'm going to look at is problem number 6 on your practice test. I've worked it out in a lot more detail than I expect that you would go through and work it out. But what we have is -2 is in front of two terms inside the parentheses. We need to use the distributive property to multiply that out. So on the first line underneath there in red, you see -2 times 5x plus -2 times -1. That takes that -2 and multiplies it by both of those terms. We don't do anything with the 3x, so we just write it down again. On the right-hand side, we've got -2x, which was there, and it's like we have an imaginary 1 in front of that parentheses with the 2x and the -14 inside of it. On the original problem, that -1 was not there, the one that's in red, mixed up with the black numbers. So what we want to do on that is pretend like there's a number in front of it, just like on the left-hand side. So we're going to take -1 and multiply it by everything that's inside the parentheses. So on the right-hand side, then, we're going to have -2x and then plus our -1 times 2x plus the -1 times the -14. We've got to remember that when there's a sign in front of that number, it goes with it. In this case, it's a negative sign, so it has to go with that -1. When we go through and multiply now, we get -10x plus 2 plus 3x on the left, and -2x plus -2x plus 14 on the right. So we've done step 1, which was to multiply things out, simplify it, and get rid of the parentheses. Now what we're ready to do is on our equation solving process is step number 2, is combining like terms alike that are on the same side of the equation. So on the left hand side we see -10x and 3x. We're going to combine those by adding together the numerical coefficients. That gives us -7x. We bring down the plus 2. On the right-hand side, we've got -2x plus -2x, so it's going to get more negative. It's -4x, and then we bring down the 14. Now you're going to go ahead and work the problem as you've been doing in the past, where you go ahead and move variables so they're on the same side and move numbers so they're on the same side. And then we're going to go back to our lecture note. On page 10 of section 2.1 lecture notes, there's this statement, and it says not all equations have solutions. That means that they're not really equations. When you can have that is when you're possibly doing some homework problems and there's a problem that's put in there just to give you experience. The main time that it really happens, though, is when you have a word problem and you're trying to put it in some kind of a form using variables and numbers. So if it's put together improperly, then you could result in an equation not having a solution. If we take a look at this one, we have 2x minus 3 equals x plus 1. It looks pretty good to start with, but if we go ahead and we start working it, on the right hand side, if we combine like terms, we get 2x plus 1. If we look at this, we've got 2x minus 3 is equal to 2x plus 1. If we were paying attention, it would be like if you have $2 and you take away 3, would be equal to $2 and you get 1. So it doesn't make any sense already at this point, but we're going to go ahead and continue as we've always done and get all the variables on the same side. So we're going to subtract 2x from both sides, and when we do that, we get -3 is equal to 1. at that point it's obvious that that cannot be and it's false. So it would give us an equation to which there is no solution. You will not have any of these for homework. You will not have any of them on a test. On the next page of your lecture notes, at the top of the page, you can read this, and the textbook actually has one of the better explanations that I've ever seen for solving problems and for doing word problems. So if you would read 178 to 184, it will give you a really good idea of the 5 steps for problem solving. This actually makes a very good concept application if you want to do that, and it will also help you on working problems 25, 27, and 31. Also realize that those homework problems that you have are in the solutions manual and the answers are in the back of your textbook. One reason that I ask that you do them is just so that you can see several applications of how word problems are actually useful. I know that word problems are difficult for most students, and I'm not going to have any of them on the test. The only 3 that you're going to have for homework are these 3 that are listed right here and the ones on your homework assignment. Formulas also make a good idea for a concept application. We're actually not going to go ahead and talk about this, and I have deleted the 4 problems that dealt with formulas out of your textbook. If you want to do a concept application and go ahead and read the remainder of these lecture notes, you may, and they make very good concept application papers if you wish to go ahead and do that. So from this point right here on, there will be nothing else in section 2.1 that you're responsible for, either on homework or on the practice test. And I'm going to stop the video right here and then continue with what I ask you to go ahead and do secondly, which is section 1.2.